Right, where am I? Following reaction system, need this and I need a pen. Right, the following equilibrium system, 2NO plus O2 gives me 2NO2. 13.2 moles of NO and 9.4 of O2 are allowed to reach equilibrium. At this point, 4.5 moles of NO2. Oh, that's terrible. Right, so what is the expression for the equilibrium constant? So Kc
Product over
equals, yep, but what about the, what is it of the products?
Concentration.
Concentration of the products, and the products is NO2 divided by the concentration of the reactants, and that is NO and O2. Now, it's 2NO2 I'm forming, and I'm using 2NO, so what do I put into my expression here?
2 at the top.
2 at the top here and 2 there.
Yeah.
So the equilibrium expression is Kc equals NO2 squared over NO squared by O2. Yeah? Okay, calculate the value of Kc. So now it wants me to work out what Kc is. And to do this, I'm going to use my Rice table. Okay? So I'm going to write, oh, it's here, so I'm not going to write it out. The ratio, or will. So I have NO, I have O2, and I have NO2, and the ratio is 2 to 1 to 2. So R for ratio, 2 to 1 to 2. So it tells me moles. It tells me 13.2 moles, okay? And it tells me 9.4 moles, and it tells me 4.5 moles. Can I work in moles?
Yes. No.
So Rice table, what I have to work in? The bottom line of my Rice table has to be in concentration, okay? Yes? Does it give me a volume here?
One.
No? It doesn't. So I'm going to assume that it's a 1 litre flask, okay?
Is it always if it's not given?
If you're not given it, the easiest thing for you to do is assume that it's a 1 litre flask, okay? And the reason that that's the easiest thing to do is constant, so moles equals volume times concentration divided by 1,000. So concentration equals moles times 1,000 divided by the volume, okay? 1 litre is 1,000 centimetres cubed, 1,000 millilitres. Okay, so if you imagine it's a 1 litre flask, this cancels out and that cancels out. Okay? So here and here alone, you can work in moles. You just need to show me that.
Right,
Okay? Yeah?
So we just like what, 1 in 1,000?
Volume 1,000. So you write assume 1 litre flask. Assume 1 litre flask. Therefore, moles equals concentration. So if you write that
So
on your
you go
page.
there, would you go there for 1,000 milliliters?
No, 1,000 milliliters if you want. No,
Yeah,
if you
yeah.
write assume with an E, spelled correctly. If you write that, then I know you've got it.
Yeah.
Okay. So I'm told 13.2 of NO. NO initial is 13.2. Initial of O2 is 9.4. How much NO2 did I have to start?
You had 13.2. No.
NO2. How much
Oh,
NO2
so you
did
didn't
I?
have
How much NO2 did I add to that
4.5.
flask?
4.3.
None.
None.
None. I had none of it at the start. So I is the initial concentration. I added this, I didn't add any of that. Okay, so this starts off as 0. I'm told at equilibrium it contained 4.5 moles of NO2. So here should be 4.5. Okay?
Yeah.
What's on here? I'll give you another wee helpful thing that I thought, okay? You see here where I do the ratios, okay? You see if it's on the left hand side, I want you to write plus, and minus, okay?
Yeah.
Because I'm using these and I'm getting rid of that. Okay, in fact, we'll do it the other way. We'll do minus, and plus, okay? Because I'm using this, so it's going down, yeah?
Yeah.
And this is getting made, so it's going up. So minus on the left, plus on the right. So what is the difference between 0 and 4.5?
4.5.
So the change is 4.5, okay?
Mhm.
And the ratio is 2. Okay? So if I go over here, here it's the same ratio, it's minus 2. So what was the change here?
Minus 4.5.
Minus 4.5. Okay?
Mhm.
So it's the same, it's the opposite. I'm using this
Mhm.
and I'm making that over the other side. So I'll put a plus here. What is the difference here?
Minus 2.25.
Why is it
Because
2.25?
it's one.
Because it's half
It's
of
one
it. Yes,
ratio,
so it's
isn't it?
1 to 2.
Yeah.
So minus 2.25. And then when you get to this point, you check that you're right, okay? So this number should be double that number. This should be 2, this should be 1. Okay?
Mhm.
So when you get to that point, make sure you've done it right, in case you've doubled it by accident. So the ratio should be 2 to 1 to 1. So check it and write 2 to 1 to 2. Okay? With me? Right. So I started off with 13.2 and I used 4.5, then what have I got left?
8.7.
8.7. Started off with 9.4, used 2.25. I have 7.15 left.
Yeah.
Yes? So these are the numbers that I want. And I'm going to put them into my equilibrium expression. So the concentration of NO2 is 4.5 squared. The concentration of NO is 8.7 squared. And the concentration of O2 is 9.15, not squared. Okay? Yes?
What is that? 7. Oh, okay.
Why is 9.5?
Because the O2.
Here. So it's 9.5 because you
Because there's only one.
started with 9.4.
Uh-huh.
You used 2.25. So 9.4 take away 2.25 is 9.15.
7.15.
7.15. And that's what you said. I just wrote it down wrong. 7.15. Yes?
Yeah.
Right, so now I'm going to solve my equation. 4.5 times 4.5 is
20.25.
20.25.
What did you say? Nothing.
20.25, yes. 8.7 squared is
75.69.
75.69. Right, so solve the bottom line for me, Sinead.
541.1835.
And then solve the whole thing for me.
Hang on. Got it to 1 second.
0.03.
0.037417.
So 0.03741.
Yeah.
Right, so I'm going for 74 and I'm leaving it there, okay? Calculate the value of Kc, and then it says, why are there units of Kc? Show how you arrived at this answer, okay? Can I rub this out?
Yeah.
Yeah. So I'm going to go back. I can get rid of everything that I've got here.
Do we need to put the units then into this? Part B?
If the next question doesn't ask you for units, put them in.
Right.
If it does ask you for units, then you probably not get penalised, but I would put them in anyway, okay? So what I'm going to do here is I'm going to do what I did right at the start of the class. I'm going to say concentration is measured in moles per decimeter cubed. That's squared, so it equals mole dm to the minus 3 times mole dm to the minus 3. And it's divided by mole per decimeter cubed squared times mole per decimeter cubed. So that's mole dm to the minus 3 times mole dm to the minus 3 times mole dm to the minus 3, and then I can cancel.
Yeah.
If I have one on the top and one on the bottom, I can cancel. One on the top, one on the bottom, I can cancel. So the units are 1 over moles per decimeter cubed, and then I have to flip it. So when I flip it, it becomes mole to the power of
Minus.
1,
Yep.
decimeter to the power of
Plus 3.
3. Okay, so the reason it's mole to the power of minus 1 is because actually up here it's mole to the power of 1, but we never write to the power of 1 because it's just itself. Okay, so when I flip it, invert it, I invert the indices. I just, if it's 1, it goes to minus 1, if it's minus 3, it goes to plus 3. This is the answer here.
But you did, if you want that written off, that's.
So the answer here is show what are the units for Kc and show how you arrive at the answer. If you write down mole to the power minus 1 decimeter cubed, you'll maybe get 1 mark.
So, but if we do that, we
But if you
want
do-
five things, whatever, and go.
Do exactly that.
Right.
And if you like maths and you can do it a different way, then do it the other way. Do it another way.
What does a
Like a
smaller
triangle.
body?
It's nothing to do with a triangle.
Joking.
D.
Okay, what does the small value of Kc tell you about the equilibrium?
Slow.
Tells you that.
The reverse was bigger.
It's the equilibrium lies very far to the left hand side. If it's a tiny, tiny, tiny number, it means that you get hardly any. Okay? The
So
bigger
what-
the number is, the more product you get. So if you have a massive number, you get loads of your product that basically goes to completion. If you have a tiny number, you basically get bugger all.
So say it again, equilibrium lies.
To the left hand side.
And can you draw that?
Oh, but you don't need to. That's just my quick way of
Right,
saying
so
it.
just
Like,
equilibrium lines and then
Left
one
hand
side.
side.
And then if
That's
there's a
your
big
answer.
number, if it says, what does a big value of Kc indicate? Equilibrium lies to the right hand
right
side.
hand side, yeah.
Small left, so you go small to high. Think of it,
Yeah.
number small to high.
Right, a homologous series of family of compounds have the same general formula and slow gradation in physical properties, show a gradation in physical properties. Alkenes and alkenes are blah 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 blah. Name the alkene with the molecular formula C5H12. What is it?
Pen.
Ian, pentane, yes. So my elephant prances before pain.
He hates October, November, and December.
That's wonderful. He hates October, November, and December. Very good. Very good.
Because you've got
You can go
October,
right up to 10.
non, December.
Very good. Very good. So it's pentane. Alkenes and alkenes undergo combustion reactions. What is meant by the term combustion? What is it? Burning it. Okay? That's literally burning an alkene
The
right there.
answer is
Burning it. Burning an oxygen.
okay.
Burning an oxygen or air. To form carbon dioxide and, in this case, water. Or a reaction with oxygen. There's so many ways you can say it. Burning in air to make carbon dioxide and oxygen. Carbon dioxide and water. I'd go for.
It's 5 or
Yeah.
S over there.
So what you know about combustion says write a balanced equation of complete combustion of propane. Propane. I just assumed that it was the following on from the previous
The
question. So
pentane.
C3 propane, okay?
Yeah.
So you either remember CnH2n plus 2 or you remember prop is 3 carbons. There's my 3 carbons. Each carbon needs 4 bonds. So this one currently has 1, it needs 3 more. There's some hydrogens for it. This one is 2, needs 2 more hydrogens. That one needs 3. So it's C3H678. Okay, so C3H8 plus O2 gives me CO2 plus H2O, and then you're back to balancing your equations. 3 carbons here, so I'm going to have to produce 3 CO2s. I've got 8 hydrogens, that's going to mean 4 waters. So carbons are balanced, hydrogens are balanced. The only thing that's not
Okay.
balanced is my oxygen. I have 6 here, 4 more there, so it's 5. Right, because remember when we're learning about isomers and stuff, I says go home and draw out as many isomers as you can of some compound. Did anyone do it?
No.
No, it was so
Some
long
of
ago.
them,
so I can do it.
Yeah.
Did anyone do it?
No,
Yes.
No, the people that did it are lucky. Name compound A. What's A? How many carbons?
Two.
So, what?
No. F.
F,
Ethanol.
right? What class of compound is it?
No, it's not. No, it's al.
Acid. Ethanoic acid. Okay. And this one over here, how many carbons? 3. So it's prop. Okay. It has a bromo. The bromo's on what number carbon?
3.
No.
1.
1. So it's 1 bromo. It has a double bond. No. Propene. Prop 1 in. So 1 bromo.
Can I take a
Prop
picture?
1 in. You're taking a picture of that?
Yeah.
It's on the
It's on the
internet.
I know, but I want to have
Say
it
that
on
one
my
again,
phone.
sorry. Pro.
1 bromo propene.
1
Propene.
bromo.
Propene.
Protein. Yeah, because they don't have.
And I don't actually have to say prop 1 in because
It's
it's in
assumed.
the 1 bromo. Okay, so this is 1, 2, 3, 4, 5 carbons, so that's pent. It's all single bonds, so it's going to be an ene rather than an ene, and it has an OH, and OH is an alcohol, so this is 2 pentanol. So it's the alcohol groups on carbon number 2 is 2 pentanol. And this one is anybody?
Butadiene.
Right, see the second, explain why the compound B is not a hydrocarbon.
Yeah. Why is it not a hydrocarbon?
Because it's got a pro.
Because it's got a bromine.
Just 'cause
Simple as that. It's got a
Okay.
bromine. So what is it? It was on the test that you did tonight.
Oh, it's
Alcoholite, yes,
alcohol.
well done. Alcoholite. It's an alcoholite and it's alkene as well.
Right, draw an isomer of carbon
D.
D. So that's just moving the carbon.
So they're all in a big chain there. So I don't want them to be in a big chain. The easiest way to do it is for me not to have a chain. So if I've got a chain of 4, now I have a chain of 3.
And have one coming up.
And I'll have 1 carbon coming out the middle. I can't draw it coming out at the end because I'm
But
not
you'll still have a
changing it.
chain.
Okay, so then I need to put in my carbons. Each carbon needs 4 bonds. This one has 4, so he
Can we-
needs 3 hydrogens.
Can we draw just,
Lines?
Yeah, I guess.
no,
No, this.
the other way you showed.
Oh, this way.
Yeah.
Yeah.
Like that there.
Do that.
Yeah.
Easy peasy.
And that's it.
That's it. How many lines was that? 3 lines?
Yeah.
You can't beat that. 3 lines for how many
So we
marks?
go for 3. 1, 2, 3, 4.
3 marks. A line per mark.
Name it.
Name it. What is it? What's the longest chain?
3.
3. So it's a
Pro.
prop. Prop.
Propane.
Prop. It's a prop. Okay, but it has something on it. What does it have on it?
Well, an yeah.
What's this called?
Me,
Yep. Methyl. And what carbon's it on?
2.
So it's called 2
Pro. 2.
methyl. Okay. So if you were given a compound and it was 5 carbons, 1, 2, 3, 4, 5 carbons long, you're asked to draw isomers. So 4 carbons long now, there's 1 isomer. 4 carbons long, is that a different thing?
No, so.
Same thing, only upside down. So we'll go for 3. It's still the same thing.
4, yeah.
So there's only 1.
Yeah.
Okay.
And then, so if that's a 3 marker, then would you get 1 for drawing the thing and 2 for naming it, do you think?
Yeah.
Right.
Okay. Draw an energy profile diagram for an exothermic reaction. Okay. So is it 5 marks? 4 marks, right? That's probably a mark. Okay. So coordinate. There's probably a mark. Okay. Next mark's going to come from, so I'll say SN and I'll say P, start materials products. I've got a wee hill in between them. That'd probably be enough, but that's doesn't ask me for activation energy, but I'm going to draw it in. So I'm going to write EACT, and I'm going to write minus delta H, and that should be me.
What does ASM mean?
Yeah.
Starting material.
Or
So
reactant
starting
or
material,
something.
reactant, product. So whatever you're comfortable.
Like penalized for writing reactant.
No. Well, as long as as long as I understand what you mean.
Yeah, but that's what I would be.
Ah, that's fine. We'll change the reactant. You State Hess's law. Hess's law states that the energy change for a reaction is the same regardless of the pathway taken.
We'll just rewind Brian there again.
Yeah.
The energy change for a reaction remains constant no matter what route is taken. Okay? So there's a height difference between Belfast and Newry. Okay? And if you go from Belfast to Derry to Donegal to Newry, the overall height difference between the two places hasn't changed. Has it? No, you just took a longer way to get there. That is Hess's law. The total difference, energy difference between what you start with and what you finish with doesn't change no matter how you get there. Okay? There may be more ups and downs, so you can maybe do it in one step, or you can do it in 12 steps, but the distance here is exactly the same. Okay? So I can go from here to here to here to here to here to there to there, eventually to here, but this difference is the same as that difference, and that's what Hess's law states. So the energy change for a reaction is the same regardless of the pathway chosen. Calculate standard, right? We're on Harold Hesse, boy. Your favourite and mine. Do you want me to try and teach it a different way?
Yes.
Really?
Yes.
Really?
Yes.
For my way you'll never go wrong. Right. Calculate the standard enthalpy of combustion. But there's no easy way of doing this. There's
There is.
It's only 2 marks.
Okay. It's 2 marks. Like
It works like it's.
all of that for 2 marks.
Two marks.
I know I wouldn't be wasting a ton of time on it, yeah.
2 marks. Right, well I'm gonna do it the way I do it. Oh, just dropped my notes here. Just hold on, we starting there, boys.
Can we get copies of those?
Done it my way. Done it my way, right. So I've got ethanol, I've got oxygen, I've got CO2, and I've got water, okay? And really what this question wants me to realise is that I can start off with carbon, hydrogen and oxygen, okay? And I can burn carbon, hydrogen and oxygen and make CO2 and water, okay? Or I can choose to grow a plant, to make some sugar, to convert the sugar into ethanol, and then to burn the ethanol and get carbon dioxide and water, okay? So I'm going to do the same thing twice. Up here, at the top, I'm always going to start with the simplest things. I'm going to start with carbon as a solid, hydrogen, H2 as a gas, and O2 as a gas. So that's what I'm going to put up the top, okay? And then down here, I'm going to put ethanol, C2H5OH. So I can take these and I can convert them into ethanol, okay? Yes? Or I can take them and I can burn them and turn them into CO2 plus H2O. Okay? So my choices are get some coal, some hydrogen, burn it, and make CO2 and water. Okay? Or take some coal and hydrogen, turn it into ethanol, and then burn the ethanol and make CO2 and water. The length of these two lines has to be the same as the length of that line. Okay? Yes? So here it says when I've got carbon and I burn it and make CO2, the delta H is minus 393.5. Okay? So for carbon, it's minus 393.5. How many carbons do I have?
3. No, sorry.
It is 3. C3, H7OH. Okay? So 3 carbons. I've got 3 carbons up here. I've got 8 hydrogens all together. So that's 4H2. I don't care about oxygen. Okay? So I've got 3 carbons, so it's this number times 3. Is that okay? I'll do it again after if you want. Why do you not like this?
I'm trying it this way that Paul showed us and see do I get the same answer here.
Okay. Well, you should. Paul taught you the right way.
I don't know.
I've got hydrogen, okay? Whenever I burn hydrogen, I make water, and that gives out minus 286. So for hydrogen, it's minus 286.0. How many of them do I have? I've got 4 of them. Okay? Do that first. That one and that one. Right. Top one is minus 1180.5, and the bottom one minus 1144, and then add them together. 1180.5 here, plus minus 144 minus 2324.5. Okay. The question tells me that if I go from carbon plus hydrogen plus oxygen directly to propanol, it's minus 302.7. Minus 302.7. Okay? So the length of this line here must be the difference between these two. Okay? So it must be the difference between these two. So I'm going to take the big number. I'm going to call this delta H1, delta H2, delta HR, just so I can write it down, okay? So I'm going to call this one delta H2. Delta H2, take away delta H1 equals delta HR. So delta H2 is minus 2324.5. Take away minus 302.7 equals minus 202.1.5. 202.1.5. Oh, it is 8 because I'm doing maths in my head and shouldn't be.
You got minus, I don't know where, so I got a plus, I got at the end of, but it's actually
No, it should be if you're burning ethanol, you know it's going to give you out heat. Do you want me to do another one then?
Why do you work? Let me get it. Right. This at the top?
Yes.
What do you get
Your simplest stuff goes at the top, okay? Because I've spent loads of time doing Hess's law, I know what goes at the top. The simplest things, so you're given 3 equations, okay? So you're given carbon plus oxygen gives you CO2, and carbon plus hydrogen plus oxygen, okay? So the simplest things you've got here is carbon, hydrogen, and oxygen, CH and O. Okay? So here's C and O to give me something, and CH and O to give me something. So the CH and O go at the top. They just
So
do.
that's the middle one.
The CH carbon. So if you get a question like this, you put your carbon, your hydrogen, your oxygen at the top. Okay? That's what you do. Okay?
Okay.
And then you say, all right, I can take my carbon and the hydrogen and the oxygen and I can make a complicated thing from it. Okay? So I draw a line showing me making the complicated thing. The complicated thing is C,
Complicated thing is always the first equation to get.
this one down. So it
No,
does,
that
it
one up
mightn't
there.
be, it mightn't be. Can you see the carbon, hydrogen and oxygen are simpler than C2, C3H7OH?
Yeah.
Yes?
Yeah.
Practice it.
Okay.
So your carbon, your hydrogen, your oxygen go at the top, okay? And I can choose to make this for my carbon, hydrogen and oxygen, and then I can burn that, and what I get is CO2 and H2O. Or I can choose to just burn this at the start, and what I get is the same thing, CO2 and H2O. Paul was showing you something like this, wasn't he?
Yeah.
There's no difference, really, apart from the way that it's drawn out. Do you realise that?
But it's I just can't get that box thing in my head, so that's why
Right,
you're just
so
kinda-
Paul said you can go C3H7OH to CO2 plus H2O. And does it give me the numbers?
Yeah.
3 and 4? Yeah?
Yeah.
Or he said then you can go down here and you can form
So it's minus.
carbon, hydrogen and oxygen, and then you can go from there to there. Is that what he did?
But we just worked out.
Yeah.
What the
If
C-
you like the way Paul does it, do it that way.
Mhm.
I'm not going to try and reinvent the
I
wheel.
just worked out what each of them 3 things was, but I've done the reactants as minus instead of reactants being positive. Change the symbol, and then the products are minus.
There's a reason that I do Hess's law like this, because it's the right way to do it. It just is.
I'm just gonna send Paul the link. That's
This is, Paul, this is the right way to do Hess's law. Because whenever you're doing a complicated thing, whenever you're trying to work out, right, we'll show Hess's law diagram for formation of ammonia. Right, there's another Hess's law diagram there. That's for the formation of what? Aluminium oxide from iron. Give me a complicated one, will you? There's a complicated one. Right, so here I am asked to work out the enthalpy change, and I have to know all of these enthalpy changes inside my head. So you were told to remember some enthalpy changes: enthalpy for neutralization, enthalpy for electron affinity, enthalpy for this, enthalpy for what, okay? So what people do is they imagine they have this thing over here. They imagine they have something and they think, is it possible for me to turn that into this other thing that I want to? And the only way where it will be possible is if this is higher than this over here, okay? If it's not like that, it's not thermodynamically possible to do it. So a Hess's law diagram, and yes, this one's very, very complicated, is the only way you can work that out. And your way of doing it, you would shit bricks if you had numbers all over the place like that. So this way, although you have to make a diagram out of your head, it does make sense. So at Queen's, they asked me to draw the Hess's law diagram for the formation of ammonia, and there was something like 13 different lines on it. 13 different lines. Up, down, here, there, everywhere. But that's the way I have to do it. So I'll do the next one, okay? And I will post a video for Hess's law. Calculate the enthalpy change. Right, I've done that. Explain why no value has been provided for the standard enthalpy formation of oxygen. Anybody?
It just burns away.
What?
It just burns away, doesn't
No.
it? No.
You don't need it.
No. What does oxygen exist as?
Okay.
So there you go. You don't form it, that's the way it comes.
Alright.
That's the way it comes, that's the way you buy it. Right, these are the easy ones. 5 marks for the easy one. 5 marks for the easy
I
one
know,
and
2
2 marks
marks
for
for the-
fucking the hard
Yeah.
one. You're taking the piss, as my brother who's lived in England for too long would say. Right, the enthalpy change for this reaction can also be calculated with blah-de-blah-de-blah.
Alright, so
Okay,
you get the
so what am I? It's
Left hand side.
C3H8OH7.
7. Oh, sorry. 8,
No,
sorry.
you're right.
8.
No, I've got no H.
Oh, right.
I want my OH there, okay? So C3H7OH. Okay, and Right, back on, see what the reaction is.
3 CO2.
3 CO2, 4 H2O.
And you don't worry, do you do the O2? No, you don't worry about the.
No, 3 C. Oh no, I do want the O2.
Yeah.
3 O2 plus 4 H2O.
Yeah.
And leave my
4.5
O2.
O2.
4.5.
Yeah.
C3H7OH plus
4.5.
4.5 O2. Right. So I'm going to work out what bonds are getting broken and what
See,
bonds are
I
getting
would have
made.
read that as 4.50.
But then you have squared, but you know it's O2.
I can't help you,
Hmm.
Katrina.
What else
And
is it
it's
to do?
26 minutes
I know,
past
but I
9.
know in
Right,
numbers
right.
it's more.
That's what was
Right,
confusing me.
okay? So what I need to do is work out what bonds I've got, okay? So the bonds that I've got 3 carbons, 1, 2, 3, and I have an OH, okay? So here are some hydrogens, here are some hydrogens, here is an OH. So I've got CH bonds, I've got CC bonds, and I've got a CO bond and an OH bond. Can everyone see that?
Yeah.
Yes? How many CH bonds do I have? 5. So 1, 2, 3, 4, 5 times 5 of them. How many carbons? 1, 2. How many No,
3.
C3, isn't it?
3, yes.
Okay. See, you stop letting me draw stuff wrong. 1, 2, 3 carbons and an oxygen and a hydrogen. H.
So CH is 7 then, isn't it?
H. So I have 7 CHs. I have 3 CCs. No, 2 CCs.
Why 2 CCs?
Because there's a bond between these two.
Yeah.
So, right. Do you agree that that's the structure? If I rub out the hydrogens just to make it easier?
Yeah, OIN
Right,
CO
so there's
then.
one
Right.
carbon bond, it's gone,
Yeah.
how many's left?
2, 1.
And there's it's gone.
And then it's,
And then it's not a
CO,
carbon.
Yeah.
Yeah.
Okay.
So I have 2 carbons, I have 1 carbon oxygen, and I have 1 oxygen hydrogen, okay? And I have an oxygen bond. How many do I have? How many oxygens?
1.
No.
4.5.
4.5 of them. Okay? So I now need carbon, hydrogen is 413. 7 times 413. Someone do the maths for me while I'm writing it down.
2891.
Oh, 2891?
Yeah.
Alright, I have 2 carbons, that's 2 times 3, 4, 7.
694.
694. I have 1 carbon oxygen, that's 1 times 360 is 360. I have 1 oxygen hydrogen, that's 463.
4408.
And 4408 for the last one,
No, that's it.
for oxygen.
Oh, sorry. Forgot about the. I forgot about
No.
the action.
Oxygen, 2 oxygens, so it's 4.5 times 498.
4.5 times 498. 2241.
2241, and then the total
6649.
6649 kilojoules per mole, and they have to be, every one of those has to be broken. Okay? The ones that get made, so I have carbon oxygen double bond, I have 2 of them. There's CO2, okay, so I have 2 carbon oxygen double bonds in each one, and I have 3 CO2s. Yes? So how many C double O bonds do I have? Many C double O's? No.
2.
Look, I need to count the number of C double bond O's. So CO2 is this.
6.
This is carbon dioxide. It's carbon double bonded to 2 oxygens, okay? So each one of them has 2 double bonds, and I have 3 of them all together.
6.
So the total number of C double bond O is 6, and that's 6 times 803 for a total
4818.
of
4818.
4818, and I have 4 waters, and each of those waters I have an OH. So how many OH bonds do I have?
8.
8 is right. So that's 8 times 463 equals
3704.
3704 for a total of
8522.
8522. Okay, so delta H equals bonds made, take away bonds broken. So I've got 8522 take away 6649
1873.
1873 kj per mole.
We're minus 1 yet.
Oh, there's more!
One more.
Alright, compare the two. So the first time using Hess's law, I got what number?
2021.
2021, and this time I got minus 1873. So which one's more accurate?
Which one has it?
Hess's law is more accurate. Hess's law is more accurate.
Why would you explain the difference?
It doesn't ask you to explain the difference. It says, oh, compare the enthalpy change obtained using bond enthalpies to that using Hess's law and explain the difference. Okay, so the difference is that these are all idealized, okay? So carbon-hydrogen bonds, if you imagine every carbon-hydrogen bond there is, all the different types of them, the average is 713, okay? But actually, here you have a carbon-hydrogen bond with a carbon next to an oxygen, okay? So it's definitely not going to be 713. This one over here might be 713, but this one's only going to be 640. And this one over here is going to be 640. And these two will be somewhere in the middle, they'll be 700. Okay? So these are averages.
So one more answer.
Averages. Averages.
Just can you just
This,
Hess's law is
so
better?
the second method, the bond enthalpy method uses average bond energies. Hess's law uses actual values. What?
Can we stop the recording?
No, I'm just taking a wee seat. Have you any other questions?
What do you pass?
What?
How many questions do we need to pass?
61.
150 marks.
There's 150 marks in that whole test.
I know it's a lot of marks. What are you telling me? Keep pointing at it for?
Can we stop the recording?
Can you stop recording? They want me to cheat. They're not going to be disappointed. Internet.